Hello everyone, welcome to Infinity Learn by Sri Chaitanya and I'm Ravindram. I'm going to discuss your physics portion of LTC AIIMS test, that is weekend test 18. Okay, so let's quickly get on with the first question. So the first question has been like this, is like this, where you have to find out the magnetic field at the center due to the circular coil as shown, right? So there are two circular coils, if you can see, one is with radius r1, another one is with radius r2. Can you see that? Yes, okay. So if you need to find out the magnetic field at the center, you need to find out the magnetic field through both these elements. That means through circular coil R of radius R1 and circular coil of radius R2 both. Now we have a formula for some fraction of a circular coil if given is given. For example, here in the first coil, if you see 3/4 of the fraction is given, and of the bigger coil 1/4 is given, and these two wires are not going to produce any magnetic field here because this point is lying on their axis. Number one. Number two, so how you're going to find out the magnetic field B1? See, the magnetic field B1 will be mu naught I by 2 R1 into 3/4, because the total is 3/4 fraction is there of this complete circular coil. Similarly, when I talk about B2, so what is happening here? In B2, as you can clearly see, that 1/4 of the portion is there, right? 1/4 of the portion is there, and the magnetic field will be mu naught I by 2 R2 into 1 by 4. Now what you're going to do in order to get the value of total magnetic field, you have to add both these magnetic field here. Can you see that? Now why am I adding? Because the directions of the sense of direction of the current is same, right? In the first coil also it is going anti-clockwise, and in the second coil, that is the coil with the bigger radius, it is also going against anti-clockwise. So that is why the direction of the magnetic field through both the coils will be in same direction, and hence we can directly add them algebraically, and we can say B1 plus B2 will give you the net magnetic field. I hope it is clear. Next question. So two long conductors separated by a distance d. Okay, so they have mentioned that the distance between these two conductors is d, right? And they carry current I1 and I2 in the same direction. Remember this thing, point number one, that if two wires, I'm so sorry for that, that two wires, if they carry current in same direction, then they tend to attract each other, and if they carry currents in different directions, then they repel each other, right? So since they're carrying current in same direction, so they're going to attract. Now what is the formula? Can you see this? The formula is written here. It is F by L, again sorry, F by L is mu naught I1 I2 by 2 pi d. This is not the force overall, it is the force per unit length on the wires, right? So these are the forces that they are experiencing. Now it is directly proportional to I1 into I2, the product of the current in both the wires, and inversely proportional to the distance between the wires. So they are saying that one of the wire the current is increased to 2 times, right? But the distance is also increased to 3 times. So overall effect will be what? In the numerator it will be 2, and in the denominator there will be a factor of 3. So overall the force will change by a factor of 2 by 3. Can you see that? Yes or no? So the answer will be F dash will be 2F by 3, because you double the current and triple the distance, right? Now question number 3. Two parallel long wires carrying current I1 and I2 such that I1 is greater than I2. Perfect. When the currents are in the same direction, the magnetic field at a point midway between the wires is 30 microtesla. Okay, so let's say that this is the point P where we need to find out the magnetic field. So at this point, the magnetic field is initially B1, as you can see here. So what is this? Mu naught I1 by 2 pi R. Let's say since it is midway, and let's assume that the distance between the two wires, they are not mentioned, but we will take it 2R. Okay. Now, B1 will be, see, the magnetic field due to the first wire will be inside into the plane, but the magnetic field due to the second wire will be out of the plane. So obviously they will be in opposite directions. So when the currents are in same direction, the magnetic field in between them are in opposite directions, so they tend to cancel out each other. So we will say B1 is mu naught I1 by 2 pi R minus, as you can see here in this formula, mu naught I2 by 2 pi R. Can you see this formula? Right? Now similarly we will find out B2 once the current reverses. That means now I1 and I2 are in different directions. Then the magnetic field due to both these wires will be into the plane. So because of which they will add up. So next case, if you see, as you can see in the formula, mu naught I1 by 2 pi r plus mu naught I2 by 2 pi r. So we are going to add the magnetic field through both these wires. And if we take the ratio, then mu naught by 2 pi r will get cancelled and V1 by V2 will become I1 minus I2 upon I1 plus I2. Why I am doing I1 minus I2? Because they have already mentioned this fact that I1 is greater than I2. Yes. Question number 4. Simple Ampere circular law is used here. Nothing, its only statement is given. If it is B vector B dot vector dl, the complete integration of over a loop is mu naught times I enclosed. This is I enclosed. And if enclosed current is 0, then we can say that there is no magnetic field at the surface, right? Now here, they have given us a proton. We know the mass of proton. We know the charge on a proton. It is accelerated in a cyclotron having external magnetic field 0.7 Tesla. So they have given us the magnetic field also. So what do we know in this question first of all? We know the mass. We know the magnetic field they have already mentioned. We know the charge on the proton. Already these three things are known. Then they have already given the radius of the Ds. So what they are asking is just the kinetic energy of the proton. So it's very simple. Do we have any formula related to radius and kinetic energy? Yes, the formula number 1. Can you see this here? Radius is mv by vq and mv is the momentum. And momentum can be written as root over 2mk. Root over 2mk. Can you see this? Now upon vq will remain as it is. So what we are going to do is we are going to say the shift, we are going to shift every parameter and then finally say kinetic energy is r square b square q square by 2m joules. Now we want answer in mega electron volts. That is an interesting fact here. So we have to be very careful that r square b square q square by 2m we have to solve by putting every value, but you have to make sure that see 1 joule is 1 upon 1.6 into 10 to the power minus 19 electron volts. And if you want to convert it into mega electron volts, you have to further divide it by 10 to the power 6. That I have done particularly here. I have divided by this value and this value. Then my answer will surely come out in mega electron volts. Are you getting it? So this is an interesting fact, and if you do it properly, you'll definitely get answer 76. Right. Question number 6. A long solenoid carrying a current produces a magnetic field B along its axis. If the current is doubled and the number of turns per centimeter is halved, the new value of magnetic field is. See, the question is, the formula is very simple. It is mu naught n I. And what is n? N is capital N per upon L. Okay, total number of turns per unit length. So if you double n and half the current, okay, or whatever it is, if you double current and half the number of turns per centimeter, then what will happen? Magnetic field will remain same because you are saying 2I into n by 2 into mu naught. So obviously B dash will still remain equal to B. Question number 7. A long solenoid whose length is given, total number of turns are given, current is given. That means everything is given and the value of mu naught is also given. What else you need? Put the formula, get the answer. Two toroids. See, in a toroid, remember one thing, that the magnetic field is directly proportional to the overall number of turns, number 1, and it is inversely proportional to the radius of the toroid, the mean radius of the toroid. So I can say that B is, I can write down point number 3, that B is directly proportional to N upon R, right? So B1 by B2 will become N1 by N2 into R2 by R1. Put the values, get your answer. Question number 9. Now again, they have given two wires carrying current I1 and I2. Can you see that? Now they are saying there's a null point in between where the net magnetic field will become 0. This is the null point where the net magnetic field will become 0. Now how to deal with this point? Obviously, since the currents are in same directions, just now we have seen, if the currents are in same direction, the wires, the magnetic field in between them will cancel out each other, will be in opposite directions. So because of I1, the magnetic field B1 will be into the plane. B1 will be into the plane using the right hand rule. like this. Can you see the thumb is going like this? So the curl is like this. So into the plane, right? And because of I2, definitely it is outside, right? Because the thumb current is like this. Upper portion, this is the wire, this is the current. At the upper portion, the current is coming out. So B1 minus B2 should be equal to 0. Put the values and get your answer. We know the magnetic field due to a long current carrying wire. It is mu naught I by 2 pi R. What is the magnetic field formula? Mu naught I by 2 pi R. Just put the value of I and R properly and get your answer. If you solve it, definitely you get these results, right? Now question number 10. A magnetic pole of strength. Okay. So pole strength they have given us. That is 1 unit. Moves 10 times. So number of turns that it took is 10 times. Around a long straight wire carrying a steady current of. Current is also given pi ampere. Now very carefully let's do it. Very carefully. See, as we know that in electrical analogy, force is Q into E and work done is force into displacement, right? Similarly, in magnetic analogy, instead of charge, we have taken magnetic pole strength. So force will be M into B and work done will be F into displacement, right? So we will say that work done is equals to MB into displacement is 2 pi R into number of turns, because one turn is 2 pi R and how many turns are there? N turns, right? So we can say that small m into what is B? B is mu naught I by 2 pi R. This is the magnetic field due to a current carrying wire into 2 pi R into N. So after solving this, definitely you will get the answer. Work done will be mu naught I into N number of turns. Remember this thing. So put the values and definitely you will get your answer. Do you understand this, guys? Question number 11. Here they want us to find out what is the net force on this square or cube square loop, right? ABCD. So let me write down. This is point A. This is B, this is C, and this is D. Now, very carefully see, students. Since the wire AB is closer to this infinitely long wire, this is an infinitely, where it is. This is an infinitely long wire, right? So I can say for sure that the forces acting on the wires are F1, F2, F3, F4. As you can see, the force on AB is F1, the force on BC is F2, CD is F3, and DA is F4. Now the thing is, the orientations of BC and ED are completely symmetrical to the wire XY. That is why the forces acting on BC and AD will be equal and opposite in direction, because their orientations are symmetrical, but the currents in both these wires are in opposite directions, right? Do you understand? Yes. Perfect. 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 So this is the thing. Now, the force on the wire AB, the force on the wire AB will be stronger as compared to the wire CD. Why? Because AB is closer to the infinitely long wire and CD is away from it. So let's find out the force on wire AB. So force per unit length, we know formula. We know this formula. Now force per unit length is mu naught I1 I2 upon 2 pi d. So what is the overall force if you want? If you know the length, then it's pretty much very easy for you. 2 pi d into L. So that is what we are doing here. So for F1, mu naught I1 is capital I, I2 is small I, right? Upon 2 pi, the distance is L by 2. This distance is L by 2, right? And the overall length of the wire is L. So mu naught capital I small I into capital L upon 2 pi L by 2. What is F3? Now for F3, what is the overall distance? This is 3L by 2. So D is 3L by 2. Right? So mu naught I1, I2. I1 is capital I, I2 is small I. Into length is L upon 2 pi into D is 3L by 2. Now you know F1 and you know F3. Now what you have to do? These are in opposite directions, you can find out. See, the current in AB is in the direction of the wire, so they will attract each other, and the current in the wire CD is opposite to the current carrying long wire. Obviously they will repel each other, so F1 is going to be of attractive nature, F3 is going to be repulsive nature, so hence they are in opposite direction, so we will say F1 minus F3 will give you the resultant answer, right? Question number 12. This is a brilliant question. This is a brilliant question. What we will do, let me write it down for you. See, here what we are going to do, we are going to say that this is A. Now this is a NOT gate. What is this? This is a NOT gate. So after NOT gate, A becomes complementary A bar. Then A bar comes here and A bar again through NOT gate. One more time, NOT gate, A bar. So A bar NOT gate will become A. Do you understand? Now this A is going here, this A is going here, and it will reach here and here also. And this A bar will definitely, this A bar will definitely reach this point, right? As you can see. Now this is what? This is a OR gate. So that means inputs are A bar and A. So we can say the resultant will be A plus A bar, right? And this is A. Now this is an AND gate. So we have to say that it is A plus A bar and A. So obviously this result comes out to be A. This is a very common result. Do you understand? So first option is correct. Let's move on to the question number 13. In the circuit below, A and B represent two inputs and C represents the output. See, what I'm going to say is if this is also forward bias, this is also forward bias, so current will flow from both of them. If the current flows, then the potential of A and C will be same, and current will flow here, and this is already 0 volts, right? So current will flow here, and here the potential will become equal to V, whatever is the potential of A or C, right? Or B, right? But if both are reverse biased, then what will happen? Then there will be no current, and the potential of C will remain 0 only. That means the potential of C will be V volts only if there is current, and if there is no current, the potential at C will also be 0. So if any one of them is forward biased, then C will have the same potential at A or B. Any one of them. If both of them are reverse biased, then the potential at C will be 0. And if both of them are forward biased, so obviously what kind of gate it looks like? You can see it's OR gate. Do you understand? Of fish, oh my god, this is a question very simple. You will say, sir, this is the simplest question. Just have to remember the concept. So this is a fish, you are viewing it from outside. This is what? Depth D. You are viewing it from here. Obviously it will appear to be at a depth D dash, and we know that formula. Okay, what is D dash? D dash will be D by mu relative. And what is mu relative? It is mu of object upon mu of observer. That means refractive index of the medium in which object is kept upon refractive index of the medium in which the observer is kept. Now let's begin with step number 1. So step number 1 is, what is delta D? It is D minus D dash, right? Then D becomes D into 1 minus 1 by mu relative. This is understood. Now let's move on to the second point. Mu relative is this. We put the values and get our answer 4 by 3. Now we put the values again in equation number 1, and your answer comes out to be 3 centimeter. This is clear. Question number 15. Now they are asking for critical angle of incidence. It is sine inverse 1 by mu. In fact, it is sine inverse. I should write it like this. Sine inverse mu of the rarer upon mu of the denser medium. And here in this question, mu of the rarer is 1 because it is air, and mu of the denser is mu, and hence I can say directly the answer is sine inverse 1 by mu. Now what is mu? Mu is C upon V. What is C? Speed of light in vacuum upon V, speed of light in medium. Speed of light in medium is C by 2, half of the speed of light in a vacuum. So it becomes 2. So mu is 2, put the values, answer is 30 degrees. Got it? Question number 16. See the frequency, the formula of frequency of oscillation of a bar magnet or a magnetic compass or a magnetic needle in a vibration magnetometer is 1 by 2 pi root over mv by I. So F is directly proportional to root B. right? So if you increase the magnetic field to 4 times its original value, then obviously the frequency is going to get double. Question number 17. This is also interesting. So they have mentioned two things here. An object is placed at a distance 40 centimeter initially, then it is brought to a distance of 20 centimeter. And they are asking you what is the displacement of the image. So what you do, you find out V1, that is initial position of the image. Then after displacing the object, what is the next position, that is V2 of the image. Then you subtract from the magnitude of V1 the magnitude of V2, okay, or vice versa. So first I have taken U1 I will take -5. This is a simple reason. This is a concave mirror and I treat in a concave mirror that this direction of measurement is positive and this direction of measurement is negative from the pole. So if object is here, so obviously U is measured in this direction and focal length is also measured in this direction. That's why U and F both are taken negative, right? So U is taken -40 and F is taken -15. Put the values, V comes out to be -24 centimeter. That means V comes out to be on the same side as our object, right? Next is U2 is -20 centimeter. Again, you put the same. Similarly, you put the values, F is -15, U is -20. Put it in the mirror's formula and finally get your result, okay? And in this case, V2 is going to come out to be minus of 60 centimeter, and if you take the difference, it will come out to be 36 centimeter. Are you understanding, students? Is this clear or not? Just let me know. In case you have any doubt regarding this, please ask in the chat box, okay? On the comment section, I will definitely come there and answer, okay? Now, lens maker formula is applicable to obviously thin lenses and for a parallaxial rays or parallaxial set of rays with subtend a very small angle on the principal axis. See, it is valid. I'll tell you. First of all, the lens should be very thin. That means the distance between the curvatures, this distance should be very less. Next point is this, that the parallaxial set of rays that are coming, they should be very close to the principal axis so that the angle subtended by these rays on the lens is very, very less. Got it? Then only it is possible. So this you have to remember. Question number 19, we use goggles, right? But they are curved, but they don't have any power. The reason is that they have infinite focal length or power is zero. How? Because they have got curvatures like this. So R1 and R2 both are measured in this direction and both are of same magnitude. Okay, so these curvatures are similar in the direction and similar in the curvature radius of curvature. Then obviously this 1 by f will become 0 and power will become 0 because power is what? 1 by f. Got it? So first and second both statements are right. The phenomena used in optical fibers, everybody remembers that, is total internal reflection. We all know this because in optical fiber what happens? This is the core and this is the cladding, right? And the light is incident like this at some angle. Then what happens? It gets totally internally reflected here like this, and again internal reflection takes place, and like this it goes on and on and on and on and it travels, right? It carries the information. 21, the critical angle of light passing from glass to air is minimum for, see, IC is equal to sine inverse 1 by mu, and mu is inversely proportional to the wavelength of the light that is incident. That means IC is directly proportional to sine inverse lambda. So lambda is minimum for violet light and hence IC is minimum for violet light only. That is clear. Now question number 22. Now what we are doing is we are seeing the bubble inside a transparent cube made up of some material or glass like material from first phase and then from the second phase. Can you see that? So from the first phase we obtain its depth to be d1 dash, that is 6 centimeter, which is what? Obviously the depth is d1 by mu. D1 is x, let's assume it to be x. This is the bubble and this distance is x as it is given, right? This distance is x. So d1 by x, that is d1 by mu, d1 is x, so x by mu. So x by mu is 6 centimeter. Then again, if you're observing it from here, that will become 15 minus x. So d2 by mu, the new depth will be 15 minus x by mu, which is 4 centimeter. Now if you take the ratio, or you can just simply do like this, you can say 15 minus x by mu now. So instead of x, you write 6 times mu upon mu, it will become 4. So 15 will be equal to 10 mu, and then anybody can say that mu is 1.5. Do you understand, students? Question number 23. Obviously, everybody knows whenever wave travels from one medium to another, its frequency remains constant, but its velocity and its wavelength, they change. Okay? Doesn't matter whether it's going from rarer to denser or denser to rarer. If it changes its medium, its frequency remains constant, speed and wavelength changes. Now, small object placed 10 centimeter in front of a plane mirror. See, this is a plane mirror. Very easy. So where is the image obtained of an object if it is kept like this? This is an object kept like this here. How much distance? 10 centimeter. So obviously its image will be obtained here only of the same size but laterally inverted 10 centimeter. So if an observer is here and he is observing, so this is how much? 30 centimeter from the mirror. I'm so sorry. So this observer is 30 centimeter from the mirror. So obviously this is the image that he will observe. So that overall distance will become 40 centimeter, right? Any doubt in this? No? Let's move ahead. 25. A ray of light is incident normally. See, if this is a plane mirror and the ray of light is incident like this, that means it is parallel to the normal. And if it is parallel to the normal, then what will happen? It will go like this only, right? And I will be equal to R will be equal to 0 degrees. Now, bar magnet means a north and a south pole, right? A north pole and a south pole. But we can also treat north pole as positive pole strength plus M and south pole as negative pole strength minus M. So this is a magnetic dipole. A bar magnet is also a magnetic dipole which is placed perpendicular to a magnetic field, as you can see here, right? So obviously the force that it is going to experience, every pole is going to experience a force of mb. We all know that through charge analogy, electrostatic analogy, right? And here what is the force? Here also the force is mb but in opposite direction, right? So we know that what is the magnetic moment? The magnetic moment is capital M, that is small m into length of the bar magnet. Force is small m into b. Let's take the ratio and we can say that L comes out to be magnetic moment into B upon F. Do you understand? This is how you get your answer. Question number 27. They have mentioned that the torque required to deflect a bar magnet in a uniform magnetic field through an angle of 60 degrees is this. Okay. So when it is at an angle of 60 degrees, what is the torque experienced by it? 25 Newton meter. What is the formula for torque? Vector M cross vector B, where M is magnetic moment, B is magnetic field. So it becomes MB sine theta. So it is 25 already given, MB sine 30, 30 degrees is given. So MB becomes 50. This is equation number 1. Now let's move ahead here. Theta 1, they want us to find out the work done in rotating it by further 30 degrees. That means, see, already it is 30 degrees. They want us to further rotate it so that the angle becomes 60 degrees. Right? This is the direction of magnetic field. This is the direction of magnetic moment. They want us to rotate it further by 30 degrees. That means theta 1 becomes 30 degrees, theta 2 becomes 60 degrees. So what is the formula for work done? MB cos theta 1 minus cos theta 2. Cos theta initial minus cos theta final. So put the value of MB. Theta 1 is 30, theta 2 is 60. Put every value and definitely you will get this right answer. Got it? Question number 28. An isolated unit, everybody forgets to read this, unit north pole. That means M1 is equals to 1 unit. M1 is equals to 1 unit. force is given. So they have given us here, they have given us force, they have given us distance, they have given us m1, but they haven't given us m2. So do we have any formula between two magnetic monopoles? Yes. It is mu naught m1 m2 upon 4 pi r square into f. Just like in electrostatics, you know, k q1 q2 by r square, where k was 1 by 4 pi epsilon naught. Similarly here we do that. Instead of q1 you write m1, instead of q2 you write m2, instead of k you write mu naught upon 4 pi. That's all. Similar assumption, oh, sorry, similar. It's an analogy here. 29. A body A of mass 4m. So m1 is given. A is moving with speed u. u1 is given. Collides with another body B of mass 2m. m2 is given. At rest, that means u2 is also given. So we have been given m1, m2, u1, u2. Collision is elastic in nature. That means E is also given. That is 1. So u1, u2, m1, m2 and E is given. We have to just find v1 and v2 first of all. So how we will find out? We will use this equation number 1 and equation number 2. Equation number 1 is momentum conservation before and after collision. Second is equation of coefficient of restitution. Then K lost is initial kinetic energy minus final kinetic energy. Can you see that? This is what initial kinetic energy minus final kinetic energy upon initial kinetic energy. This is what? This is your fractional loss in kinetic energy. So first you find out v1 and v2 using the first and second equation. Then you put their values. Everything you know, everything is given to you. I haven't written. M1 is also given. It is 4m and m2 is also given, which is 2m. So every little thing is given to you. You can do it, right? Now, question number 30. For any collision, momentum transfer takes place? Yes, always, always. No doubt about it, always. In any collision, energy transfer takes place? May or may not. May or may not, right? Because if you take that special case where a mass m is moving with 2 meter per second, right? And if another mass is there, right, it is also coming with 2 meter per second. This is m. If you take this particular special case, this is A, this is B, then what will happen after collision? A will go back with the same speed, 2 meter per second, and B will also go in this direction. Their velocities will get exchanged, but the kinetic energies are still same. So there is no transfer of energy in this particular special case. That is why this is little bit false. Impulsive forces are involved, definitely, because whenever they collide, the force that acts is of huge magnitude and acts for a very short span of time. So these are definitely impulsive in nature. Okay. Question number 31. Very simple. X1 is given, X2 is given. They are asking for location of center of mass. Use the formula and get your answer. Again, this is a very, very old and common question of angular momentum conservation. I1 omega 1 is equals to I2 omega 2. I1 will be, it's a ring, so m r square, and then first it is just a ring of m and radius r. Next time it is a ring with 2 point masses, small m here and small m here, and this ring is capital M radius r. Now obviously these point masses will have their own moment of inertia m r square, so we have added it here, as you can see. That's all. Now you put the values and get your answer. Use this equation number 1, right? Now question number 33. Three identical masses. Can you see three identical masses? This is mass number 1, mass number 2, mass number 3, or you can say this is mass number 1, 2 and 3. So this is m3, I suppose. This is m1, let's say, and this is m2. And we have to find out, this is your axis. Now since these two masses m1 and m2 are lying on the axis, their moment of inertia will be 0. And this is the perpendicular distance from the axis of m3. r is definitely root 3 l by 2, so you put the values. You will say, sir, moment of inertia of m1 m2 will be 0, so only of m3 will be there. M3 r3 square, let's say this is r3, right? r1 r2 are 0, r1 is 0, r2 is 0, r3 is this. Okay, so you say moment of inertia will be m3 r3 square, and what is r3? R3 is root 3 L by 2. Now root 3 L by 2 whole square, this is going to become what? 3 by 4 L square. Why? Because mass is 1 kg. Do you understand this? So this is your moment of inertia, 3 by 4 L square. Got it? Question number 34 again, just like in work power energy, we have already studied that power is force into velocity or vector F dot vector V. Similarly, here torque is also, sorry, power is also in rotational dynamics, torque into angular velocity or angular speed, right? So what is torque? Power upon angular speed. Now what is angular speed? If in terms of, see, angular speed is given in terms of rotations per minute, we have to convert it into radians per second, right? We need to convert it into radians per second. So multiply by 2 pi by 60, 2 pi by 60, do it, and the answer comes out to be 100 pi, right? And then finally put it, power upon angular speed. Now it is given 3.14 kilowatts. So write down 1000 also here, right? And we can write 100 pi as 100 into 3.14. So this 3.14 and 3.14 will get cancelled, and your answer comes out to be 10 Newton meter. Right. Question number 35. Now there's a hollow sphere. This is a hollow sphere. Now this hollow sphere is going forward with VCOM is equals to V, and it is rolling. So this is omega. And if it is rolling, then V equals to R omega. Right. So first of all, what is the overall kinetic energy? Rotational plus translation. That is half mv square plus half I omega square. Now what is V? R omega. What is I? 2 by 3 mr square. It's a hollow sphere, right? If it would have been a solid sphere, 2 by 5 mr square. Now rotational kinetic energy is what? Half mv square. And what is the overall kinetic energy? It is half mv square plus half I omega square. Now I is 2 by 3 mr square and omega is V by R, right? So put values and definitely you will get your answer as 60%, right? Question number 36. Now this is interesting. Let's say this is your x-axis and this is your y-axis, right? And this is your z-axis. Now if you look at BP, that is the magnetic field due to this coil P, this is, it will be B1 in this direction, and that will be how much? Mu naught I1 by 2R I cap. And if you talk about this other one, that is BQ, or this another one, so the magnetic field due to another coil will be in this direction. This is B2. Let's say this is B2. So B2 is what? B2 is mu naught I2 by 2R. Radius are same. J cap. J cap. This is interesting, right? Now obviously I cap plus J cap, that means how we will add them? We will say B net will be B1 square plus B2 square under root. Do you understand this? So mu naught by 2R will be common, and I1 square plus I2 square under root will come out, right? Question number 37. Here this charge, electron is what? Electron, what is the charge on electron? It is minus E. Now what is the force acting on the charge if it is moving with velocity V in a magnetic field B? It will be minus E into V cross B, vector V cross vector B. You do this. V cross B. V, magnetic field is inside. V cross B. Where is the thumb going? Up. The force is up. But it's a negative charge, so force will come down. Do you understand? So overall the force will become this. E V B times minus J cap according to the question. Right? So it is gonna go down. So first of all, magnetic field does not change the kinetic energy, doesn't change the speed of the charged particle. So V is gonna remain equal to U. So either second option is correct or fourth option is correct. But V is gonna be less than 0. Why? Because the charge is gonna go like this. Like this. Do you understand? And eventually it is gonna come out here with the speed V. Got it? that will be equal to U only. It is not gonna change. Clear? Fourth option is correct. So with full confidence, you will say fourth option is correct. Now question number 38, you need to find out magnetic field. This is very simple. I'm not going to explain again here. Just find the magnetic field due to this wire, then this wire, and both are in same direction into the plane. Into the plane. Oh, not into the plane. See, because of I1, the magnetic field B1 is into the plane. But because of I2, the magnetic field is out of the plane. So B2 is out of the plane, right? So mu naught by, so answer will be like this. Mu naught I1 upon 2 pi A minus mu naught I2 upon 2 pi B if the current. Okay. Okay. So mu naught by 4 pi, I can say 2I1 by A minus 2I2 by B. Which option matches? Come on quickly. Tell me guys. Second option. Very good. You are very intelligent. Now use Ampere's circuitial law. Using Ampere's circuitial law, there is a logic. Suppose if a wire is given like this and this wire completely carries current like this. Okay. So the current is carried everywhere in this complete cross-sectional area. Then for any point that is inside the wire and for any point that is outside the wire. So if any point like this or any point like this, the formula for magnetic field is different. Do you understand? So for inside the formula, for outside the formula is this, right? For outside, let me change it to R1, R2 like this, otherwise you'll get confused. Okay, so for outside, what is the formula? Mu naught I by 2 pi r, simple. Put the values, get your answer. Small r will be 2r. It is written, everything is written here, right? And your answer is 10 microtesla. Now, if you talk about the point that is inside, the formula is this. Mu naught I by 2 pi capital R square into small r, that is a distance. So if you put the values, small r is r by 2, put it, and your answer is mu naught I by 4 pi r, which is exactly same to B1, that is 10 microtesla only is the answer. Whenever a wire of any shape is kept in a uniform magnetic field, the formula for force acting on it is I into L effective into B. The condition is L effective must be perpendicular to magnetic field, must be perpendicular to the current. Sorry, not must be perpendicular to the current, must be perpendicular to the magnetic field. In that case, you can take theta as 90 degrees and answer will be this. Right? Now, L effective is what? Join these 2 points. This is the effective length. That's all. Okay. So, put the values, get your answer. That's all. 41. Now, here this is a fixed wire and below it there is another wire. Now, this another wire is carrying current I2 and we have to find out the direction of the current, and also that the net force on it is 0. So obviously because of mg it is going to go down, but if it is staying in air or floating in air, that means another force is coming up. And which force can come? Because of the presence of this wire, the other force that is coming is FB, right? So this FB is the magnetic force. This FB is the magnetic force. What is the magnetic force? We know this formula, right? Mu naught I1 I2 by 2 pi d, and we want the upper wire to attract the lower wire upwards. That means the current should be in the same direction. So current should be in the same direction, same as first. Now whether the value is 25 or 49, we need to find out. So we will say mu naught I1 I2 by 2 pi d is FB by L. That is force, magnetic force per unit length should be equal to the weight per unit length mg by L. That means this. So we equate these two forces and finally we get the answer 49 ampere, same as first, right? Question number 42. Now here see, since it is a loop, So whatever is the whatever is the magnetic field due to the first element of wire, in the same direction the magnetic field will be there because of other elements also. So we just need to find out the magnetic field due to one single element, and we know the magnet in multiplied by 3, we will get the magnetic field at the center through all these three elements or three sections AB, BC and CA. So what is the formula due to one element? The formula is this: mu naught I by 4 pi r into sin theta 1 plus sin theta 2. Theta 1 and theta 2 are these. If you remember, the formula is this. Suppose this is a current carrying wire. This is a point. This distance is r. So this is theta 1 and this is theta 2. Right? And the formula is mu naught I by 4 pi, mu naught I by 4 pi r into sin theta 1 plus sin theta 2. Are you understanding? This is due to a single element multiplied by 3. Now have to be very careful. The distance r is this. This is your distance r, right? This is your distance r, this length. Got it? And this r is L by 2 root 3. Remember this thing. Theta 1, theta 2, 60 degrees. Find B, multiplied by 3, get your answer. Answer will come out to be the first option. 43. This is an interesting one. See, refractive index of air is given, which is little bit greater than that of vacuum. So thickness, or the distance, I should say the distance that light covers in vacuum, is T, which is equals to n wavelengths in lambda. And if the light passes for the same duration in air, then how much distance will it travel? It will travel mu t. And it is saying that as compared to air, as compared to vacuum, in air it is traveling an extra wavelength. That means n plus 1 into lambda. This is the actual optical path in air, right? Geometrical path is t only, but optical path is mu t. So if you take the ratio, find out, t comes out to be lambda upon mu minus 1. Otherwise, one more shortcut we can use here, students. We can say that they are saying that one extra wavelength is there in air. That means if you consider air to be a medium, air to be a different medium as vacuum, then the extra path that is traveled is lambda. And what is extra path? We all know mu minus 1 into t. This is lambda. So t is what? Lambda upon mu minus 1. That logic also we can use. Okay, question number 44. A ray of light passes from vacuum into a medium of refractive index mu. Okay, angle of incidence, see, I is given 2r. So from here we can say r is equals to I by 2. So sin I, that is 1 dot sin I, is equals to mu dot sin r. Then can I write sin I as 2 sin I by 2 cos I by 2? Yes. Which is mu sin I by 2. So obviously these two will get cancelled. And now rearranging it, we will get I equals to 2 cos inverse mu by 2, right? Now let's come to question number 45. This is a simple question where they are asking you to find out the location of the object from this particular point. Let's call it pole only, right? So here the formula that is used for refraction through spherical surface is mu2 by v minus mu1 by u into mu2 minus mu1 by r. Mu2 is given. Mu2 is the refractive index of the medium in which object is kept, no, in which the observer is there, or in which the image is going to be formed, or in the medium in which refracted rays are there, right? So these are your incident rays, definitely, and these are your refracted rays. So this is refracted rays, these are incident rays. So this medium will be mu1 and this medium will be mu2. So mu2 is 2, mu1 is 1, and r is plus 20 because this is the direction of incident rays, and this direction we take positive. R is center of curvature is here, so r is measured here, u is measured here, so u is negative minus 10, and r is plus 20. So what is v? Use this formula, get the answer. Answer comes out to be 40 centimeter, 46. Now here, what is the power? First they have given the power of the lens. From there you can get the value of f1. What is f1? F1 is the focal length when it is in air. When it is in air, and when it is in dipped in another medium of refractive index mu, then f2 is minus 100 centimeters. So use their sign properly. We know that 1 by f1 will be this refractive index of the lens upon refractive index of the medium minus 1 into 1 by r1 minus 1 by r2. Similarly, 1 by f2 will be refractive index of the lens upon refractive index of medium minus 1 into, we already know this formula, right? That 1 by f is equals to refractive index of the lens upon refractive index of the medium minus 1 into 1 by r1 minus 1 by r2. So in the first case, mu of the medium is 1, and in the second case, mu of the medium is mu. Mu of the lens in both the cases is same because we have not changed the lens. It is 3 by 2 or 1.5. Do you understand this? Solve it, take the ratio, solve it, answer is 5 by 3. Now we are cutting this bar magnet into 4 sections. So when we cut it into 4 sections, its mass becomes 1/4, length of each bar magnet becomes 1/2, 1 by 2, right? So magnetic pole strength becomes half, right? So mass become 1/4, length becomes half, magnetic pole strength becomes half. Now what is the formula for time period? This is 2 pi root over I by mb. Now what about moment of inertia? It is mass ml square by 12. So if mass becomes 1/4, length becomes half, put the values, moment of inertia becomes 1 by 16. Now, what about magnetic moment? Magnetic moment was pole strength into length. If pole strength becomes half, length becomes half, this becomes 1/4. So put it I by 16 upon m by 4. The new time period will become half. Got it? 48. Again, the same kind of question they have given. In this question, I'm not going to waste time. M1 is given, M2 is given, U1 is given, U2 is not given, V1 is given, V2 is also not given. So two variables are not given and E is also given. So you have to use two equations. Equation number 1, that is momentum conservation. Equation number 2, that is coefficient of restitution. Once you know V2 and U2, VC is very simple. Just find U2. Just find out U2. VC is M1 U1 plus M2 U2 upon M1 plus M2. This is the third equation that will give your answer. Got it? Now here they are saying that angular momentum is conserved. So L is constant. If L is constant, tau is what? dl by dt will be 0. If torque is 0, that means force and position vectors are perpendicular or are parallel to each other. That means F is equals to kr, k times a constant times vector r. So we can compare and say that A is equals to 2k, 3 is equals to minus 6k, and 6 is equals to minus 12k. So if you solve it, you will say that 6 is equals to minus 12k. So k is minus half. Or we can also say it like this. 3 is equals to minus 6k. If 3 is equals to minus 6k, then also k is coming out to be minus half. So we can use this and say if a is equals to minus k, if a is equals to 2k, I'm so sorry. If a is equals to 2k, then what is k minus half? So a becomes minus 1. Got it? So this is the right answer. These are two parallel vectors actually. Last question. If you cut this string, the only force that is acting is mg downward, and it's gonna provide a torque. Torque is I alpha. Torque is what? Mg into perpendicular distance. What is this perpendicular distance? L by 2. This is torque. Mg into perpendicular distance will be equal to I alpha. I about this axis is ml square by 3 into alpha. That's it. Alpha is 3g by 2l. That's all. I hope this solution helps you a lot, my dear students. Thank you for watching this video, and I really want you all to practice this question paper once again because it's going to help you revise all these crucial topics again. Thank you so much, and please subscribe to our channel. Support us as much as you can. Thank you so much.